Today we're going to start a new unit on triangles. Let's talk about what a triangle is. So a triangle is a polygon that has three sides. Typically, a triangle will say, let's say it has vertices A, B, and C. We would call it triangle ABC, or you might notate it with a little triangle followed by the vertices ABC. Now triangles can be classified by their sides or by their angles. If you classify triangles by their sides, there are three possibilities. The first is a scalene triangle, in which it has no congruent sides. Next, you have an isosceles triangle, which has at least two congruent sides. And then lastly, we have an equilateral triangle, where all three sides are congruent. Now, classifying triangles by their angles, we have a couple of different options as well. So first we have an acute triangle. This means that all the angles inside the triangle are smaller than 90 degrees. Next we have a right triangle, where you have one angle that is a right angle. Next we have an obtuse triangle. That means that one of the angles inside of the triangle is an obtuse angle. And then we could also have an equiangular triangle, which has three congruent angles. Now notice an equiangular triangle also happens to be an acute triangle because all three of those angles are smaller than 90 degrees. So an equiangular triangle is simply a more specific type of acute triangle. Let's take a look at example 1. A triangle has the given vertices. Use the distance formula to classify it by its sides, then determine if it is a right triangle. Okay, so we have the vertex A is at 2, 3, B is at 6, 3, and C is at 2, 7. Now to classify it by its sides, we have to use the distance formula and find the side AB, the side BC, and the side AC. So let's go ahead and apply that distance formula to find each of those sides. Let's start with the distance from A to B. That would be 6 minus 2 squared plus 3 minus 3 squared. That's going to be the square root of 4 squared plus 0 squared, which is equal to square root of 16, which is 4. Next, we're going to find the distance from B to C. So now we have 2 minus 6 squared and 7 minus 3 squared. So that's negative 4 squared plus positive 4 squared, which is equal to the square root of 32. And simplifying that, we have 4 root 2. Lastly, we'll find the distance from A to C. So now we have 2 minus 2 squared plus 7 minus 3 squared. So we have 0 squared plus 4 squared, which is the square root of 16, which is equal to 4. Now we can see here we have one side that's 4, one side that is 4 root 2, and one side that's 4. So two sides have the same length, so we can say this is an isosceles triangle. Now drawing this out, we can see as well that not only is it an isosceles triangle, but it is also a right triangle because we have a 90-degree angle there. Alright, now let's talk about the angles within a triangle. So in order to properly see all angles that are associated with a triangle, we have to actually extend the sides. Now first we have what we call interior angles, which are the original inside angles. So they are kind of glowing here in this picture. So those are your interior angles. Now exterior angles are the angles that form linear pairs with the interior angles. So if we've extended this out, we can see here the exterior angles are the ones that are shaded in blue. So if you look at the top there, you can see very clearly we've extended that line, and the line that's outside of the triangle that forms a linear pair with that top angle, that is an exterior angle. And the same applies to the rest of the angles as well. Now there are a couple of theorems that go along with these interior and exterior angles. The first is the triangle sum theorem. This says that the sum of the measures of the interior angles of a triangle is 180 degrees. So in other words, if you have a triangle ABC here, the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Next we have the exterior angle theorem. Now the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Now there are a lot of terms in here, so let's see if we can understand what this theorem is saying. So here's a triangle ABC, and we're talking about an exterior angle. We'll call that angle 1. So what this is saying is that the measure of angle 1, an exterior angle of a triangle, is equal to the sum of the measures, so we're going to be adding two angles, of the two non-adjacent interior angles. Angle C is adjacent to angle 1. So the two angles that are interior angles that are not adjacent to angle 1 are A and B. So the measure of angle 1 is going to equal the measure of angle A plus the measure of angle B. Let's take a look at example 2. Find the measure of angle JKM. So it looks like here J is X, L is 70, and then JKM is 2X minus 5. So we're going to first need to relate angle JKM, which is 2X minus 5, to the information given to us. Now the exterior angle theorem tells us that this angle JKM, which is an exterior angle, should be equal to the sum of the measures of the two non-adjacent interior angles, which would be X and 70. So 2X minus 5 is equal to 70 plus X. Now we can solve for X, and we get X equals 75. Now this is asking you to find the measure of angle JKM, not what X is equal to. So now we're going to need to substitute 75 back in for X. Since the measure of angle JKM is equal to 2X minus 5, we're going to substitute that X in there for 75. 2 times 75 minus 5 is equal to 145. So our answer is that the measure of angle JKM is 145 degrees. Another way to get to that answer is to use the application of the exterior angle theorem again. So since you know X is equal to 75, and you know angle J is equal to 75 now, you can simply add 75 plus 70 to get 145. Okay, the next thing is the corollary to the triangle sum theorem. Now corollaries are some result of the theorem to which it is a corollary. So in this case, a corollary to the triangle sum theorem is some result from the triangle sum theorem. So in this case, this corollary says that the acute angles of a right triangle are complementary. Now since the triangle sum theorem tells us that the measures of the interior angles sum up to 180 degrees, then you know for a right triangle, since one of those angles is 90 degrees, that must mean the other two angles must add up to 90 degrees. So we call this a corollary because this is a result of applying the triangle sum theorem to a more specific case. Let's take a look at example 3. Find the measure of angle 1 in the diagram shown. So angle 1, which is in red, is an interior angle, but we also have all this information about the other interior angles, 3x and 40, and we also know the exterior angle is 5x minus 10. Let's start off by trying to determine what x is equal to. So based on what's in this diagram in blue, we can say that 5x minus 10 has to equal 40 plus 3x. Solving that, we have 2x equals 50. So we have x equals 25. So substituting 25 in for x in the expression 5x minus 10 is going to give us 5 times 25 minus 10, which is equal to 115. Now that we have the measure of the exterior angle, we know that the measure of angle 1 plus the measure of the exterior angle should equal 180 degrees. So angle 1 plus 115 equals 180, which means the measure of angle 1 is equal to 65 degrees. So in the diagram, the measure of angle 1 is 65 degrees. Now another way to go about this problem is to say, well, once we know what x is, we can find what 3 times x is, and then you have two of the measures of the interior angles, and then you can subtract those two angles from 180 to get the measure of angle 1. You should also get 65. Let's take a look at example 4. Find the measure of each interior angle of triangle ABC, where the measure of angle A is equal to x, the measure of angle B is equal to 2x, and the measure of angle C is equal to 3x. Now since we know that the sum of the measures of the interior angles is going to equal 180, I can go ahead and write that. So angle A plus angle B plus angle C equals 180. And since we know those measures, we can go ahead and substitute. X plus 2x plus 3x equals 180. Adding those together, we have 6x equals 180. And solving for x, we have x equals 30. So we know the measure of angle A is 30. And then to find the measure of angle B, which is 2x, that would be 2 times 30, which is equal to 60. And then the measure of angle C is 3x, which is 3 times 30, which is equal to 90. Now clearly the way that this diagram has been drawn is not very accurate, because it looks like the 3x and the 2x should probably be switched, and in order to show the difference between x and 2x, x should be about half the size of 2x. Let's take a look at example 5. Find the measures of the acute angles of the right triangle in the diagram shown. Okay, so if you remember the corollary to the triangle sum theorem, it said if you have a right triangle, then you know that the measures of the other two angles must add up to 90. Let's go ahead and use that to help us solve this. In this case, we have the x minus 6 and the 2x that should sum up to 90. Simplifying this, we get 3x equals 96, which means x is equal to 32. Now it does say to find the measures of the angles, the acute angles that are shown. So to find the measure of each angle, we simply substitute 32 for x in each expression. So x minus 6 is 32 minus 6, which is equal to 26 degrees. And then the measure of 2x is 2 times 32, which is equal to 64 degrees. So the measures of the acute angles are 26 degrees and 64 degrees.